Hello and welcome to our number basis topic. In this subtopic, we are going to talk about the base 10. In the previous lesson, we talked about base 10 ranges, hexadecimal ranges, binary ranges, octal, and other bases. We also talked about their ranges also. So now we are going to deal strictly with the base 10, meaning the decimal. And in this lesson, we are going to talk also about the expanded notation forms. What is this expanded notation forms? That is what we are going to find out. So these examples now see, express the following numbers into expanded notation form. Expanded notation form is going to be, we are going to have a number and then we are going to split it up into standard form. So those standard forms are it's just an intro, so it's just going to tell us that, okay, so this is where the number stacks up, or this is where it stands. So starting with the first one, 3298, if we want to expand or express this number in expanded notation forms, we are going to expand it some sort. So look at it very well. We have 3298, right? So how many numbers do we have here? We have 1, 2, 3, 4. So we are going to take this one on the extreme left, this 3. So we are going to write it down. Then count what is left on the right hand side. We have 3. 1, 2, 3. So we are going to say this 3 times 3 zeros. 1, 2, 3. So we write 1. 1, 3 zeros, meaning 1000, right? Then the second one is 2. So we are going to write it 2 times, how many numbers do we have on its right? We have 2 numbers on its right, so 2 zeros, then 1. Then we are going to go for the next one, is 9. 9, then how many numbers do we have on its right? We have only 1 number, so we say times only 1 0. Then we put the 1 here, and then we are going to go for the last one, meaning 8. So how many numbers does it have on its right? It has no number on its right, so we are going to leave it as only no number, empty, and then put the 1. Empty space for 0, and then put the 1. So if we want to write it now in standard form, what we are going to do is we are going to say 3 times 3 zeros mean 10 raised to power 3, plus 2 times 2 zeros mean 10 raised to power 2, plus 9 times 1 0 mean 10 raised to power 1, and then 8 times no 0 mean 10 raised to power no 0. 10 raised to power no 0. So it's very important that you understand at this stage that every number, any number raised to power 0 is 1. So that's why this 10 raised to power 0 here is the same thing as this 1 here. I hope you understand this one. So we've now expressed this 3298 in expanded notation form. Of course, no WAEC question is going to ask you this, but it's basic knowledge that you understand this one before we go deep into other bases and their conversions. So how about this one? What we are going to do is 80325. So we see we are going to take the first number here, write it down, 8, then count the rest of the numbers, the remaining numbers, 1, 2, 3, 4. So it means we are going to see times 4 zeros, 1, 2, 3, 4. Then we write a 1 on it. Then plus this 0, this one, we're going to write it down. Then times, how many numbers does it have to its right? We have 3 numbers. So we have 3 zeros, 1, 2, 3, then put a 1 on it. Then plus this next, which is 3, right? Times, how many numbers does it have on its right? We have 2 numbers, so 0 and 0. Then write a 1. Then for the next one, we have 2. So we are going to write 2 times, how many numbers does it have to its right? It's only 1, so 1, 0, and then 1. Plus 5. How many numbers does it have on its right? No number on its right, so times no number, nothing, no 0. But then we are still going to write down the 1. Alright, so now in standard form, 8 times, how many zeros? 10 raised to power 4 zeros, so 4. Plus 0 times 10 raised to power 3 zeros. Plus 3 times 10 raised to power 2 zeros. Plus 2 times 10 raised to power 1 0. Plus 5 times 10 raised to power 0 zeros, no zeros. All right, so now we've expanded or expressed this number in expanded notation form. So we are done with this one, and I don't expect you to make mistakes. Just try and as much as possible to replay the video if you don't understand. Then we also have the comment section below so that you can express whatever it is you don't understand. As for the next numbers that have decimal points on them, this is what we have: 760.24. This is also very simple, but you need to pay attention to how I'm going to do them. So it's 760.24. So we said we are going to take out this number first. So it's going to be 7 times, how many numbers to its left? Forget about the numbers after the decimal point. So 7 times, how many zeros? 1, 2 zeros. So 1, 2, 1 and 1, 2 zeros. Plus 6 now times how many numbers to its right? Only 0. Only one number to its right. So 1, 0 and then 1. Plus this 0 now. 0 times how many numbers to its right? No number to its right. So we just leave it empty, blank. Then we write the one that is supposed to be attached to it. Then now we move into the place for the numbers after the decimal point. What we are going to do for the numbers after the decimal point is very, very simple. So we're just going to write 2 times 1 over 10. So you start 1 over 10, 1 over 100, 1 over 1000. You just be increasing the zeros. So 2 times 1 over 10 plus the next one is 4 times 1 over 100. So can you guess if we had another number, what we are going to do? If we had another number here, so we are going to say plus that number times 1 over 3 zeros, 1000. So this is how we are going to do it. So now to expand it, to write it down in standard form is going to be easy. 7 times 10 raised to power 2 zeros. So 10 raised to power 2 plus 6 times 10 raised to power 1 plus 0 times 10 raised to power 0 because it has no 0 plus 2 times 10 raised to power minus 1. If we there is a topic we are going to discuss later on after this topic, or after more topics, then it's called indices. When we take a number from the bottom and take it to the top, it's going to be raised to power minus 1. So if I had 1 over 10, it's going to be 10 is the same thing as 10 raised to power minus 1. If I have 1 over 24, it's going to be 2 raised to power 24 raised to power minus 1. If I have 1 over 4 squared, it's going to be 4 raised to power minus 2 because it's now gone up. So that's what we are saying here. So 10 has gone up, so it's raised to power minus 1. Then plus 4 times this one, 10 raised to power, how many zeros does it have? 2 zeros. So we are going to write minus 2. Very simple. 2 zeros minus 2. So this is expanded notation form. So we have 7 times 10 squared plus 6 times 10 raised to power 1 plus this 0. This is 0, so we don't need to write it. Then plus 2 times 10 raised to power minus 1 plus 4 times 10 raised to power minus 2. That's all. So this one is the next one, and it's also very simple but tricky. So 0 or 0.0243. So take the first number, 0. How many numbers does it have on its right? It has no number because this is a decimal point, and we say we don't take into consideration the numbers on the after the decimal point for now. So 0 times nothing, empty, then 1. 0 times 1. Then plus 0 times 1 over 1 0 plus 2 times 1 over 2 zeros plus 4 times 1 over 3 zeros plus 3 times 1 over 4 zeros. 4 zeros. So now we are going to write it down again and say 0 times 10 raised to power 0 0 times 10 raised to power 0 plus 0 times 10 raised to power minus 1 plus 2 times 10 raised to power minus 2 plus 4 times 10 raised to power minus 3, because we have 3 zeros, we have 2 zeros here, we have 1 0 here, 1, 2 zeros minus 2, 3 zeros minus 3, plus 3 times 10 raised to power minus 4 because of 4 zeros. So this is the expanded notation form. So I hope you understand, and then the next lesson is going to be about conversions from one base to base 10. So thanks for watching.